car moving with 10 meters per second, right? All of a sudden, it, okay, and it took point 10 seconds for the car to come to rest, okay? So what we need to find the force, the average force acting on it during the time the car the coming to rest after the collision of the tree with the tree. Okay, so force is what? Force is ma, but we cannot solve this problem by using Newton's second law. This version we have to use the other version. So I quickly remind you, this is a VT graph, and the slope of VT graph is a. So a must be delta v over delta t. Then we can replace a by delta v over delta t. Now mb can be replaced by p. So delta p over delta t. Okay, so what is delta p over here? Delta p is m v final minus m v initial. Okay, m v in final must be 0. So m is 1200 times v is 10. So delta p is negative 12000 kilogram meter per second. Okay, so we're going to plug that in. F is equal to 12000 kilogram meter per second, and the t is 0.10 second. Okay, so what we have is okay, so 1212340 kilogram meter per second square. Kilogram meter per second square, yeah. Kilogram meter per second square has a SI unit, and that is Newton. So F is equal to 1.212345 Newton. 2 is the vector addition. So 60 plus x is equal to 100. 100 is the resultant. This is vector A, which is 60, and vector B, which is x. Okay. So now the answer choice given is, let's say you have to use the answer choice. They are, number 1 is 20 Newton, number 2 is 39 Newton, number 3 is 40 Newton, and number 4 is 161 Newton. Now, it's very simple. What you can do, you can write max or mean max, right? Okay, and your resultant has to be what? 100, 100, 100, 100. Okay, so that's it. Let's see who is combination give you 100. So 60, you have 60 plus what? 60 plus 20, 60 plus 20, or 60 minus 20. So 60 plus 20, I'm going to write it over here. First, we're going to do 60 plus 20. 60 plus 20 is 80. 80 is not 100. And then we're going to do 60 minus 20. 60 minus 20. 60 minus 20 is 40. And 40 is not 100. Let's do we're done with this one. Let's do 39. 60 plus 39 is not 100, is 99. So 99 is not 100. 60 minus 39, that's 21. Okay, so 21 is not 100. Let's do the other one, is done. 60 plus 40. 60 plus 40 is 100. Okay, and 60 minus 40 is, we already found the answer, but anyway, it's 20. So this one is check. All right, this one is not good, 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 this one is not good. Okay, all right, so which one is good? So far this one is good, 40. So 40 is good. Let's see, we have more answers. So 60 plus 161, 60 plus 161, 60 plus 161 is You have 161 and 61, 221. So 221 is not 100, so not good. All right, 60 minus 161. So 60 minus 161 is 101. 101 is not 100. 101 or rather negative 101. So that's not good. Okay, now let's see. This one is 0 degree. 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 This one is 180 degree. Okay, this one is 180 degree. This one is 180 degree. And this one is 180 degree. Okay, now let's only explain this one. A box. All right. And how much a vector A? Vector A is 60. Okay, so vector A is 60 degree. Okay. And vector B is 40 degree. Vector B also 40 degree. So vector B 40 degree. So they are parallel to each other. So what are you going to do? Vector A and vector B, and you add them up. What is the angle between them? Oh, 0 degree. So there we go. That's how you want to do it. The angle between these two vectors 0 degree. Three is if the sum of all the forces is 0 Newton, then the object moves with constant velocity. Why is that? So let's say an object is I don't know 10 kilogram, right? Let's see the applied force. Applied force. This is, let's say, Uda. Okay, so the FG is 98 Newton. Fn is 98 Newton. Okay, all right. So force of friction is mu k Fn. So 0.3 Fn is 98. So 98 times 3, 29.4. So this is FF is 29.4 Newton. FA is also 29.4 Newton. So this object is moving with constant velocity. Why is that? Is because the net force is 0. What is the net force? Net force that x direction is 0. Why is that? And net force is y direction is 0. Why is that? At the x direction, the box has how many forces at the x direction? X direction, you have Fa minus Ff. They're equal in magnitude, opposite in direction. So what is that? Fx is Fa is 29.4 minus 29.4, 0. Fy, how many forces at Fy? 2 forces. Fn minus Fg. Fn is how much? 98 minus 98, 0. So 0. All the 4 forces acting on it. However, the sum of all the forces is 0. So
have a bottle of ketchup. Ketchup is a pretty thick fluid. It takes a little bit of shaking to come out of the bottle, but even if we stop shaking it, the ketchup's going to continue coming out of the bottle once we keep holding it upside down.
So I'm going to demonstrate inertia using this ketchup bottle. So what just happened? So what did I do? I threw the ketchup bottle down, and even though the bottle stopped moving, you can see the ketchup didn't stop moving. Why? Because the ketchup doesn't have a seat belt. When your car stops moving, you don't stop moving. That's why when the car brakes, you try to push out of your seat. The exact same principle happens here.
A while ago, we did a demonstration where we had a toy car that went right into a brick, and there was a small marker standing on top of the car. So when the toy car smashed into the brick, the marker still had the momentum of the brick, so it would smash in.
5. I give you x-axis and y-axis. This is mass, and this is the force due to gravity, and I give you the slope. And I ask you what is the name of the slope. Well, the name of the slope, you can say Fg over mass. So Fg is in Newton, mass is in kilogram. So Newton is kilogram meter per second square. That's kilogram. Kilogram cancel. So meter per second square. What is the name of the quantity which SI unit is meter per second square for acceleration. This must be acceleration. This is acceleration, or you can call it acceleration due to gravity, because this is actually force due to gravity. So this one is supposed to be acceleration due to gravity, but you also can call it acceleration. Problem 6: a car which has a mass 7.5 kilogram moves 20 meters per second hit a car that is at rest 60 kilogram. Okay, so what do we after the collision, they stick together. Okay, this is before, this is after. They stick together. So what is the velocity? Okay, so we know that momentum before is equal to momentum after. Momentum before is m1, this is called m2, and velocity is 0. Okay, and the here velocity here is not velocity 1, velocity 2, they're together. So velocity m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. Take a look at the picture. Picture will allow you to make the correction. This is at motion, so this is 7.5 times 20. This is at rest, so this is 0. m1 and m2, they have different mass, but they stick together. When you are sticking together, you have same velocity. Velocity is equal to 7.5 times 20 divided by m1, so 67.5. So velocity is 7.5 times 20 divided by 2.2 meters per second. So their together velocity is 2.2 meters per second. You can check momentum before, momentum after holds by using the momentum equation. So you throw a ball. Okay, so let's throw a ball. Okay, with 55-degree angle. 55-degree angle. Okay, this velocity is let's say, I don't know, 12 meters per second. You throw this one, which is also 55 meters per second, 55-degree angle. However, this you double it, 22 meters per second. Okay, so you know that when you double the velocity, keeping the same angle, right? The height goes up by 4 times, and displacement also, the range also go by 4 times. Okay, so this one would be the height would be 4 times as big, and range would be 4 times as big. Let's take a look. What would be the height over here? Let's take a look. So to find the height, you're gonna use the dy is equal to v square over 2g. So v square is vy square. So vy is v sine 55. So 12 sine 55 is a negative 10. Sine 55. Yeah, 9.8. 10. So it's 10 square over 20. So it's 5. Okay. And let's see, find dx. Dx is v squared sine 2/3 over g. Okay. So as you see that this one v squared is of course v squared would be what this v squared is v is 12 v squared, so 144 sine 2 theta. So sine 2 theta is, this is 55, so 55 times 2, 110, so 144 sine 110, and that is 135. So that is 135. So this one is 135. Okay, now let's see. I predicted that 4 times, may not be 4 times. But this one is you have vy squared over 2g. Vy squared is, I double it, So 22 sine 55 is, I believe, 20, I don't know, 22 sine 55, 22 sine 55 is 18. So 18 is squared divided by 20. So 18 is squared divided by 20 is 16. So this is 16. All right, little bit more than 3 times, as you see that. This is dx is v squared sine 2 theta over g. So 144, not 144, 22 squared, 22 squared sine 484 sine 110, and that is 454. So this is 454. So 454 divided by 135. Oh yeah, it's about 4 times. Yeah. Yeah, this goes by more than 3 times. Okay, if you double the velocity, the height goes up more than 3 times. If you double the velocity, the displacement goes up by more than 3 times. All right, we need to find the inertia. So let's check it out. This one has the most inertia because let's write it down in terms of mass. Big mass, second big mass, third big mass, and then the fourth big mass. So this one has the biggest inertia. This one has the second biggest inertia. This one has the third biggest inertia. This one has almost no inertia. Okay, so answer to the question is 2000. More mass means more inertia. 9, there is an object sitting over here and 2 objects. So problem 9, there is an problem 9, there is an object sitting here and 2 forces act on this object at the same time. That's why we call it concurrently. Okay, 2 forces act on it concurrently, meaning that 2 forces act on this point at the same time with the same magnitude, however at 150-degree angle with respect to the x-axis. This is 0 degree with respect to the x-axis. This is 150 degree at the respect to x-axis, and the angle between two is 150. We can use the parallelogram formula to find the resultant. R squared is equal to a squared plus b squared plus 2ab cosine theta. We can write, yeah, or we can write big R. Okay, that would be confusing. So theta is the angle between the two vectors. So r squared is equal to 20 squared plus 20 squared plus 2 times 20 times 20 cosine 150. And if you plug that in your calculator, that's give you around 10.4 Newton. Okay, now let's go over problem number 10. Problem number 10, you have 2 vectors. The vector 1 would be 6 meter, right? Vector A is 6 meter, and vector A is 60 degree above the x-axis, and vector B is also 6 meter. Today, everything we're going to do using the parallelogram, so we can save our time. However, if you use the parallelogram, you need the angle between these 2 vectors. To understand the angle between these 2 vectors, you have to create a parallelogram. So I'm going to copy this one over here. Okay, and I'm going to copy this one over here, right? Okay, great. And we want to find the resultant. Okay, this is the resultant. Oh, they ask you to find the resultant. You don't need angle. Oh, yeah, you do need angle to find the resultant. So r squared is equal to a squared plus b squared plus 2ab cosine angle between these two vectors. Okay, let's see. What is this angle? This angle is 60, okay, because I move this one over here. So this is 60, so this is 90, so this is 150. Okay, if this is 150, this is 150. If that is 150, then this is 30. This one is 30. If this one is 30, then that's what you're gonna have to use, the angle between 2 vectors, which is 30. So let's see, r squared is equal to a squared, which is 6 squared plus 6 squared plus 2 times 6 cosine 30. Okay, so r squared is equal to 36 plus 36 plus 72 cosine 30. So let me see what it is. $62. R squared is 36 plus 36 plus 62. So plus 36 plus 36 is square root of 134. And that is 11.56. So we're just gonna say 11.6, 11.6 meters. Okay, there you go. This is problem 10. Now let's do problem 11. So problem 11 is 6 Newton, 90 degree. Vector B is 4 Newton, negative 60 degree, of course, with respect to x-axis. Okay, so this one is 90 degree, and this one is negative 60 degree. So what is the angle between these two? 150 degree. Why we need that? Because we need to use the parallelogram. R squared is equal to a squared plus b squared plus 2ab cosine 150. And thus gives you r squared is equal to a squared is 6 squared plus 4 squared plus 2 times 6 times 4 cosine 150 degree. And thus gives you about 3.2 Newton. So the answer is 3.2 Newton. That you have 4 second, 1 second, 2 second, 3 second, 4 second. Yeah, you have displacement versus time. You have 1 meter, 2 meter, 3 meter, and 4 meter, right? Okay, so what are you doing? You are moving with constant velocity 1 meter per second, and then you are resting for 1 second, and then you are, of course, with constant acceleration, constant negative acceleration, you are moving how much? Okay, so you want to find the momentum. So you want to find the momentum, momentum at 2.1 second. Okay, so how can you do that? Convert it to VT graph quickly. So the slope of this one is 1 divided by 1, which is 1. The slope of this one is 0. This is 1, this is 2. The slope of this one is v. Okay, well, the velocity initial is v. Velocity over here is 0 at 3 second velocity is 0. This is 3. At 4 second velocity is v. This is at 4 second. All right, so now you're gonna quickly find a is equal to half of bh. So a is how much? 4 minus 1, which is 3. 1, what 3 minus 2, 1, h. So h is 6. So this is 6. This is negative 6. By the way, this is vertical graph. So this one is 2 comma 6, and this one is 4 comma negative 6. So this is your x1, y1, x2, y2. So y2 minus y1, x2 minus x1. So what is y2? Minus 6. Y1 is minus 6. X2 is 4. Minus 2. Minus 12 over 2 is minus 6. What is minus 6? Is the acceleration. So acceleration is minus 6. But we need to find the momentum. So we need to find the velocity. So what is velocity? Y is equal to mx plus v. So to find the velocity, we need to use this point. So that would be your 6 is equal to minus 6 2 plus b. So 6 is equal to minus 12 plus b. So our y-intercept is 18. Okay, so y is equal to mx plus b. Y is equal to minus 6. X is 2.1. Okay, plus y-intercept. So y is equal to, this is your velocity, by the way. 6 times 2.1, and that is 12.6. 18 minus 12.6, and that will be 5.4. So your velocity is well, let's find the velocity function, I guess. Yeah, your velocity there is 5.4, right? Your velocity there is 5.4. Velocity is 5.4 meter per second at 2.1. Okay, so now what is momentum? Momentum is mv. So m is 5.4. No, m is how much? Did I give you m? M is 10, I believe. Yeah, 10. So 10 times 5.4, and that is momentum is 54 kilogram meter per second. Go over problem 13. Problem 13, you have a person. Moving up 10 kilometer. We can call vector A. And vector B, and the person turn around, right? Turn around and move 30 mile, 30 kilometer, and that's vector B. 30 degree southeast. Okay, 30 degree southeast means 30 degree below the x-axis, like this. Okay, so to use the parallelogram, we have to use the angle between the vectors. This is not angle between the vectors, so we have to draw the parallelogram. So let's copy this one. I'm going to copy this one right here, and then I'm going to copy this one. I'm going to copy this one. Okay, so now let's find this one. If we find this one, then we should be able to find this one. So this must be 60. Then this is 60. Then this must be 120. Then this must be 120. Okay, great. So we found the angle. So everything is easy now. Okay, so now r squared is 10 squared plus 30 squared, right? Plus 2, 10, 30, cosine 120. And that's supposed to give you 25.6 kilometer. Okay, so that's the final answer. Now you have a pulley and you have two masses hanging on a pulley. This one, elevator is 40 kilogram, man is 50 kilogram, together is 90 kilogram. This one is 100 kilogram. So this must be accelerating down, this must be accelerating up. However, I said that what is the apparent weight loss to that 50 kilogram person? So that 50 kilogram person is inside the elevator. So what is his weight? mg. So I ask you to use 10. So 50 times 10, which is 500 Newton. Negative 10, which is negative 500 Newton. So I'm going to put an arrow so I can remove the negative sign. So the person weight is 500 Newton. However, the scale on treat 500 Newton if there exists an acceleration. Now let's see if there is an acceleration. Let's call this is 90, of course. Let's call this one m1, this one m2. So you have m1, you have m1g, and you have ft. You have m2, m2g, and you have ft. Okay, so you have Ft minus M2G is equal to M2A. You have Ft minus M1G is equal to negative M1A. Okay, so what is Ft? Ft is equal to M2G plus M2A. So you're going to plug that in. M2G plus M2A minus M1G is equal to minus M1A. All right, so let's see. We're going to isolate M2A plus M1A. You understand the other one over there, M1G minus M2G. So we're going to now factor out over here. A is M2 plus M1 is equal to G is M1 minus M2. So A is M2 plus M1, G M1 minus M2. So G is 10, M1 is of course 100, minus M2 is 90, and this is 190. So acceleration is 0.52 meter per second square. Is that right? So 100 divided by 190. So acceleration is 10 over 19. Is that 0.52? Acceleration is 0.52. 10 divided by 19, 0.53. Okay, 0.53. Since I asked you to apparent weight loss, so you're gonna use this one. Fn is equal to mg minus a, right? Because you only experience weight loss when the elevator is moving down, right? Okay, so you negate this acceleration. Okay, Fn is mass is 50, and this is 10 minus 0.53, and that is how much? 10 minus 0.53 times 50, and that is 474 Newton. Okay, so your apparent weight loss is equal to your weight, 500 minus 474 Newton, and that is your apparent weight loss is 26 Newton.